Hello students. So we are discussing some important concepts for the 2021 NEET and Karnataka CET examination. So I have selected few important concepts from where we are getting the questions in the competitive examinations like NEET and Karnataka CET. My next concept is on dimensional analysis. I guess you know the three important applications of what dimensional analysis. So the dimensional analysis is used for the three purposes. The first application of the dimensional analysis is you can check the correctness of a given equation. Given equation, the scientific equation, whether it is dimensionally correct or the dimensionally incorrect, such a type of equations we can check with the help of what? The dimensional analysis. So what is the first application of the dimensional analysis? To check the correctness of a given equation. We can easily check the correctness of a given equation with the help of what? The dimensional analysis. So second application of dimensional analysis is we can convert the unit of a physical quantity from one system to another system. Suppose if you know the value of force in SI system, we can determine the value of force in CGS system. Suppose if you know the value of the energy in a SI system, you can convert that value into CGS system. In general, the unit of physical quantities from one system to what? Another system, we can convert with the help of what? The dimensional analysis. That is the second application of the dimensional analysis. Then the third application is we can derive the correct relation related to what? Physical quantities. Say for example, a time period of a pendulum. It depends on length as well as acceleration due to gravity. How time period of a pendulum depends on length and acceleration due to gravity, that can be derived with the help of what? Dimensional analysis. If we take one more example, say for example, centripetal force depends on mass of a body, velocity of a body, radius of circular path traced by the body. So how the centripetal force depends on mass, velocity and radius of a path. So these all things we can derive with the help of what? The dimensional analysis. So tell me, what are the three applications of dimensional analysis? We can check whether given equation is dimensionally correct or incorrect. We can check the equation with the help of dimensional analysis. Second one, we can convert the unit of physical quantity from one system to another system. The third application is we can derive the correct relation related to the physical quantities. But in this class, let me consider some of the concepts from the dimensional analysis where we can find questions in the examinations like what? Karnataka CET as well as NEET examination. So first type of example is based on the first application of what? The dimensional analysis, that is to check the correctness of a given equation. Say for example, we have the equation called V is equals to what? U plus AT. So according to principle of homogeneity, this equation is said to be correct provided all the terms in this equation should have the same dimensional formula. ಯಾವುದಾದ್ರೂ ಒಂದು ಈಕ್ವೇಶನ್ ನ ಡೈಮೆನ್ಷನಲಿ ಕರೆಕ್ಟ್ ಅಂತ ಅನ್ಬೇಕಾದ್ರೆ ಕಂಡೀಷನ್ ಏನಂತಂದ್ರೆ ಆ ಈಕ್ವೇಶನ್ ನಲ್ಲಿರುವಂತ ಎಲ್ಲಾ ಟರ್ಮ್ ಡೈಮೆನ್ಷನ್ಸ್ ಸೇಮ್ ಇರಬೇಕು, ಡೈಮೆನ್ಷನಲ್ ಫಾರ್ಮುಲಾ ಸೇಮ್ ಇರಬೇಕು. ದೆನ್ ಓನ್ಲಿ ವಿ ಕ್ಯಾನ್ ಸೇ that equation is dimensionally correct. For example, here we have the equation called v is equals to u plus at. This equation is correct provided dimensions of u should be equals to, dimensions of v should be equals to dimensions of u should be equals to dimensions of what? at. ಇಲ್ಲಿ ಎಷ್ಟು ಟರ್ಮ್ಸ್ ಇದಾವೆ ನನಗೆ? v, u and at. ಮೂರು ಟರ್ಮ್ ಇದಾವೆ. ಟೋಟಲ್ I have 3 terms. This equation is said to be correct provided dimensional formula of v should be equals to dimensional formula of u which is equals to dimensional formula of at. ಸಿಂಪಲ್ ಸೆನ್ಸ್ ನಲ್ಲಿ ಹೇಳ್ಬೇಕಂದ್ರೆ ಎಲ್ಲಾ ಟರ್ಮ್ ಡೈಮೆನ್ಷನಲ್ ಫಾರ್ಮುಲಾ ಸೇಮ್ ಇದ್ರೆ then only that equation is said to be dimensionally correct. So for checking what correctness of the given equation, we are making use of principle of homogeneity. Which principle we are using? The principle of homogeneity. Principle of homogeneity. So this principle of homogeneity is a principle which is used to check whether given equation is dimensionally correct or incorrect. So let me focus on the statement of the principle of homogeneity, because our next questions completely depends on the statement of what? The principle of homogeneity. So tell me, what is the principle of homogeneity? According to principle of homogeneity, in a given equation, 2 or more physical quantities can be added, 2 or more physical quantities can be subtracted, 2 or more physical quantities can be compared, provided they should have the same dimensional formula. ಎಂತ ಎರಡು ಟರ್ಮ್ಸ್ ನ ಆಡ್ ಮಾಡಬಹುದು ಹೇಳಿ ನಾವು? ಎಂತ ಎರಡು ಟರ್ಮ್ಸ್ ನ ಆಡ್ ಮಾಡಬಹುದು? ಎರಡು ಟರ್ಮ್ಸ್ ನ ನೀವು ಆಡ್ ಮಾಡ್ತಿದ್ರಂದ್ರೆ, ಅಥವಾ ಎರಡು ಟರ್ಮ್ಸ್ ನ ನೀವು ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ತಿದ್ರಂದ್ರೆ, ಅಥವಾ ಎರಡು ಟರ್ಮ್ಸ್ ನ ನೀವು ಈಕ್ವೇಟ್ ಅಥವಾ ಕಂಪೇರ್ ಮಾಡ್ತಿದ್ರಂದ್ರೆ, ಪ್ರೊವೈಡೆಡ್ ಆ ಎರಡೂ ಟರ್ಮ್ ಡೈಮೆನ್ಷನಲ್ ಫಾರ್ಮುಲಾ ಸೇಮ್ ಇರಬೇಕು. ದೆನ್ ಓನ್ಲಿ ವಿ ಕ್ಯಾನ್ ಆಡ್, we can subtract, you can compare the number of terms. Otherwise you can't add two dimensionally incorrect terms. You can't subtract two dimensionally incorrect terms. You can't equate two dimensionally incorrect terms. Dimensionally incorrect ಇತ್ತು ಅಥವಾ ಎರಡು ಟರ್ಮ್ ಡೈಮೆನ್ಷನ್ಸ್ ಬೇರೆ ಬೇರೆ ಇತ್ತು ಅಂತಂದ್ರೆ ಅಂತ ಟರ್ಮ್ಸ್ ನ ಆಡ್ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗಲ್ಲ, ಅಂತ ಟರ್ಮ್ಸ್ ನ ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗಲ್ಲ, ಅಂತ ಟರ್ಮ್ಸ್ ನ ನಾವು ಈಕ್ವೇಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗಲ್ಲ. ಸೊ ದಟ್ ಈಸ್ ದ ಸ್ಟೇಟ್ಮೆಂಟ್ ಆಫ್ ವಾಟ್? ಪ್ರಿನ್ಸಿಪಲ್ ಆಫ್ ಹೋಮೋಜಿನಿಟಿ. ಲೆಟ್ ಮಿ ಟೇಕ್ ಒನ್ ಸಿಂಪಲ್ ಎಕ್ಸಾಂಪಲ್ ಹಿಯರ್. ಐ ಹ್ಯಾವ್ an equation a is equals to b plus c. I have an equation a is equals to b plus c and this equation is dimensionally correct ಅನ್ಕೊಳ್ಳಿ. ಈ equation dimensionally correct ಇದೆ. According to principle of homogeneity ಏನು ಹೇಳುತ್ತೆ ಅಂದ್ರೆ, when you are adding b to c, you are adding b to c, you are adding b to c because dimensions of b and dimensions of c are same. ಇಲ್ಲಿ ಬಿ ಮತ್ತು ಸಿ ಎರಡು ಡೈಮೆನ್ಷನ್ಸ್ ಸೇಮ್ ಇರೋದ್ರಿಂದಾನೆ ಬಿ ನ ಸಿ ನಲ್ಲಿ ಆಡ್ ಮಾಡಿದ್ವಿ. ಸಪೋಸ್ ಇಫ್ ಬಿ ಅಂಡ್ ಸಿ ಹ್ಯಾವ್, ಸಪೋಸ್ ಇಫ್ ಬಿ ಅಂಡ್ ಸಿ ಹ್ಯಾವ್ different dimensions, then it is impossible to add such two terms of different dimensions. ಬೇರೆ ಬೇರೆ ಡೈಮೆನ್ಷನ್ಸ್ ಇರುವಂತ ಟರ್ಮ್ಸ್ ಅನ್ನ ಆಡ್ ಮಾಡಲಿಕ್ಕೆ ಬರೋದಿಲ್ಲ. ದಟ್ ಈಸ್ ದ ಸ್ಟೇಟ್ಮೆಂಟ್ ಆಫ್ ವಾಟ್? ಪ್ರಿನ್ಸಿಪಲ್ ಆಫ್ ಹೋಮೋಜಿನಿಟಿ. ಅಷ್ಟೇ ಅಲ್ಲದೆ ಇಲ್ಲಿ a is equals to b plus c is a given equation. One more condition, all the terms in the equation should have the same dimensions. Yes, to terms iddave, ಎಲ್ಲದರದ್ದು dimension same ಇರಬೇಕು. ಅಂದ್ರೆ what is the meaning of this one? Dimensions of A should be same as dimensions of B should be same as dimensions of C. Means dimensional formula of A ತಗೊಳ್ರಿ, dimensional formula of B ತಗೊಳ್ರಿ, dimensional formula of C you consider, all should have the same dimensions. So that is the principle of homogeneity. So this equation is dimensionally correct. Which equation? V is equals to U plus AT is dimensionally correct. Now first point ತಗೋತೀನಿ. U is added to AT. U ಅನ್ನ AT ಗೆ add ಮಾಡಿದ್ರಿ. ಯಾವಾಗ add ಮಾಡ್ಲಿಕ್ಕೆ ಪಾಸಿಬಲ್ ಹೇಳ್ರಿ ನಾನು? Dimensions of U should be equals to dimensions of AT. U ಮತ್ತೆ AT ಇದ್ದು ಎರಡರದು ಡೈಮೆನ್ಷನ್ಸ್ ಸೇಮ್ ಇರೋದ್ರಿಂದ ಮಾತ್ರ U ಅನ್ನ AT ನಲ್ಲಿ ಆಡ್ ಮಾಡಿದ್ದೀರಿ. Suppose if U and AT have different dimensions, then definitely such two terms cannot be added in science. That equation is not dimensionally correct here. So U and AT are added here because they have the same dimensions. Ashte alla, in this equation dimensions of V, dimensions of U and dimensions of what? AT is same. ನೀವು ಬೇಕಾದ್ರೆ ಚೆಕ್ ಮಾಡ್ರಿ. What is V here? Velocity. What is the dimensional formula for velocity? m0 L1 t power minus 1. Okay, velocity. Next term ಏನು? U. U is called initial velocity. Its dimensions is m0 L1 t power minus 1. Next term ಏನಿದೆ ನಮಗೆ? AT. What is AT? A is called acceleration and T is called time. Acceleration dimensional formula m0 L1 t power minus 2. It is the dimensional formula of acceleration. What is the dimensional formula of time? Time dimensional formula is t power 1. ಏನಂತ ಹೇಳ್ರಿ? m0 L1 t power minus 2 t power 1. It is t power minus 1. Look at the terms. This is the dimensional formula of V. This is the dimensional formula of U. This is the dimensional formula of AT. Okay, all have same dimensions. m0 L1 t minus 1, m0 L1 t minus 1, m0 L1 t minus 1. Therefore this equation is correct. ಇನ್ನೊಂದು ನೋಡಿ, U is added to AT. U ಅನ್ನ AT ನಲ್ಲಿ ಆಡ್ ಮಾಡಿದ್ರಿ. U is added to AT. Why? Because U and AT both have same dimensions. ಇವೆರಡು ಡೈಮೆನ್ಷನ್ಸ್ ಸೇಮ್ ಇರೋದ್ರಿಂದ ಅವನ್ನ ಆಡ್ ಮಾಡಿದ್ವಿ. ಇಲ್ಲಿ ಕ್ವಶನ್ ಬರುತ್ತೆ, ಫೋರ್ಸ್ ಅನ್ನ ವೆಲಾಸಿಟಿ ನಲ್ಲಿ ಆಡ್ ಮಾಡಬಹುದಾ? ಫೋರ್ಸ್ ಅನ್ನ ವೆಲಾಸಿಟಿ ನಲ್ಲಿ ಆಡ್ ಮಾಡಬಹುದಾ? Is it possible for you to add F and V? Answer is no. Why? Because force and velocity have different unit as well as different dimensions. That's what they cannot be added. Force na acceleration alli add ಮಾಡಬಹುದಾ? Answer is no. Force cannot be added to the acceleration because force and acceleration have different dimensions and different units. ಎಂತ physical quantities add ಮಾಡಬಹುದು ಹೇಳಿ? You are adding 2 or more physical quantities ಅಂತಂದ್ರೆ they must have the same dimensions, then only we can add such type of terms in physics it is. So that will call it as a what? Principle of homogeneity. Once again, will you recall the statement of the principle of homogeneity? What is principle of homogeneity? 2 or more terms can be added, 2 or more terms can be subtracted, 2 or more terms can be equated or compared, provided they must have the same dimensions. So this is called the principle of what? The homogeneity. Okay, so based on this principle of homogeneity, the many questions are coming in your competitive examination. Let me take such type of examples which can appear in what? Your competitive examination. Let me take one by one examples here.